This is me looking very worried because my cat called Nomi is stuck at the top of a tree meowing. Now, luckily, my fireperson friend has come to help. Now, we know some information about this, so I can turn it into a maths problem. I know the height of the tree. This happens to be 6 metres. And I was lucky enough to ask Nomi, and Omi at this point in time knew the angle of depression from him to the feet of me and the feet of the fireman. Now the angle of depression measured from the horizontal down to the fireperson was 40 degrees, and of course we know that means the angle of elevation up from the horizontal to the same line of sight is also 40 degrees then. And to sad looking Paul, the angle of depression as measured by my cat Nomi was 80 degrees. And of course, again, angle of elevation up must be 80 degrees as well. So what we have here are two right angled triangles. We know the 6 metres and an 80 degrees in this right angled triangle. So we can figure out how far I am from the base of the tree. As well, in the larger right angle triangle here to the fireperson, we know the height of the tree is 6 metres, an internal angle of 40 degrees here, so we can calculate this distance from the base of the tree to the fireperson. So I've shown these in yellow below as A and B. So I can answer the question now, how far away is the fireperson from Paul? And of course that distance is B take A. So that's a really easy problem. You've done that lots of times. But let's make this a little bit trickier. Here we see they're both in the same direction from the tree. What if the fireperson wasn't along the same direction, but instead they moved somewhere else? Perhaps they could have been at, if Paul was north, they could have been around north 30 degrees east, or they could be due east at the same angle of depression from Nomi, and clearly the distance between the fireperson and Paul would not be the same, B take A. So this diagram here, not very good in 2D to show a three-dimensional problem. So let's have a look at how we might sketch that up. The first thing I'm going to put in is the tree, and I'll keep that as a vertical line. Next I've drawn in a north-south line, but now to show the east-west line, I can't have this vertically. I need to give it some perspective, something I wasn't very good at in year 7 or 8 or 9 or 10 or later life in art, but I'll give it a go. So here I see my compass bearings, never eat soggy Weet-Bix, and then the vertical coming up. So in this problem, my cat Nomi was at the top of this tree, which I said was 6 metres high. Now Nomi observed Paul at a position, let's say that was due north. So the line of sight to Paul at a position north from Nomi was measured to be at an angle of depression of 80 degrees. So I could put that 80 degrees in here, or I could put it as an angle of elevation. I'll put it down there because it's a little bit easier to show. And then the fireperson was at a different position. So they weren't over here in the same line of sight anymore. I could draw them due east, or let's do a trickier one. Let's show them over here. So when my cat looks at the fireperson, here's their line of sight down to the fireperson. Now I need to draw in where they would walk towards the base of the tree. So that's along the flat earth. And the direction Nomi is looking at is from north, let's say 60 degrees. So this direction here is north 60 degrees towards the east. Let's just identify our right angles here. In the triangle between the tree and me, we have a right angle from the vertical down to the north line. In the triangle to the fireperson, we also have a right angle. It's a bit trickier to draw in, but the yellow line here is a horizontal along the ground, and this is the tree vertical. So I've got two right-angled triangles here. So let's draw them in solidly. So here's the right-angled triangle involving the line of sight to Paul, and then along to the base of the tree and vertically up. I've just drawn that again to the side. And now for the other triangle, we have from Nomi, the cat, to the line of sight to the fireperson, along the ground and up the tree. I also get a right angle triangle, that right angle in there. And to keep it the same as the last problem, let's say that angle of elevation is 40 degrees. So we can go ahead and use our SOHCAHTOA to solve for the distance from the base of the tree to Paul and the base of the tree to the fireperson. I won't put those steps in, but here's what you should get. So if you do this, you get Paul's 1.1 metres away from the tree and the fireperson is 7.2 metres. If we wanted to solve the distance between them, and on my 3D diagram, that is that distance there, D, I can see along the ground, I can create the triangle out to Paul from the base of the tree, the distance I want to find to the fireperson, and then back along the ground to the base of the tree. So that's a non-right angled triangle, and I know the distance from the base of the tree to Paul, and the base of the tree to the fireperson, and I know the 60-degree angle between those two sides, so I can use the cosine rule to find D. Now I'm not going to solve that question here. All I want you to do is get used to visualizing the information shown in this diagram and similar diagrams that you'll see. So here we see the vertical is kept as up and down the page. The north-south line is now right to left, and it's the east-west line that has been skewed to give perspective. Have a go at some of the questions provided